In this video, I'm going to look at how to use the cast diagram to solve trig equations. Before we do that, let's just quickly work out where cast came from. So if we go back as far as GCSE and we go back to the basic sine graph. Here's the basic sine graph. We know that our points of interest are here, where that's 90. This is 180 degrees. This is 270. And this one is 360. Let's put the 180 down there so they're all on the same line. We also know that that's 1 and that's minus 1. Now, say we were solving an equation like sine of theta is equal to, what should we make it? Let's make it 0.4. Now, the first thing you do is you pop that in your calculator and you do shift sine or arc sine of 0.4, making sure the calculator was in degrees. And the answer to that I get is 23.58. Now, you'll know that there's not only one solution to this, there are two. If we're looking at theta between 0 and 360. So let's have a look at where they come from. Well, 0.4 is going to be here somewhere. So that would be my 23. Let's call it 24 degrees. If I follow that 0.4 along, it happens to occur here. Now this is a beautifully symmetrical diagram. Okay, mine isn't, but that's the idea. So the gap between here and here and the gap between here and here are the same. So to get this solution, it's the same gap as it is from 0 from 180. So what we would do is we would do 180 minus 23.58 to get my second solution. 156.4 degrees. Now, in the cast diagram, we have the four quadrants. C stands for cos, A stands for all, S for sine, and T for tan. We were looking at sine, so sine's also going to happen when we've got 180 minus theta, and that's the bit we're going to fill in on our cast diagram. Right, let's look at doing cos. So I'm going to go back to the top, I'm going to do cos, and then we're going to fill in what cos is here. So, same kind of story. Let's have a look at the cos graph. So in a cos graph, it starts at the top, goes down, goes back up again. That there is 90, 180 is in the middle, 270 is here, and 360 is there. Say here we had that cos theta was equal to 0.4. I'm not going to work it out this time, but there's my first solution, which is actually in this one here, in all. It's between 0 and 90. And my second solution's up here. Well, once again, we're talking symmetry. So the gap between 360 and this value is the same as the gap between 0 and this value. So the other solution for cos occurs at 360 minus. So I'm filling in 360 minus theta into my cast diagram. Let's do tan using the same way. So tan, the graph of tan is that weird one where you've got the asymptotes occurring at 90 and at 270, and at 360 you've got a 0, and 180 you've got a 0, and 0 you've got a 0. And it goes up, down, up, down. Now, same thing again. If I was solving tan theta equal to 0.4, my first solution would be here. My next solution would be here. Let's have a look at the symmetry on this one. The gap between 0 and this value is the same as the gap from here to here. Now, what was this value? This value was 180. But because it's further along, instead of being 180 minus, tan becomes 180 plus. So this is actually like a little roadmap or a summary of the four quadrants of all the possible solutions. So in the first quadrant, which is 0 to 90, sine, cos, and tan are all positive. In the second quadrant, which occurs between 90 and 180, only sign's positive. See, 90 to 180, only sign's positive. Tan is the only one positive between 180 and 270. And in the last quadrant, 270 to 360, it's only cos. So this little road map, my cast diagram, becomes what I use to solve equations. So let's look at how to actually use the cast diagram. I'm going to do the 3 traditional examples. So a normal one where we have to adjust the value of theta, and the third one, what happens if I have a negative value. Hopefully this will help resolve any issues you may have on solving them. So let's start with one where I have to do it normally. Let's just do a nice normal example. So say I was solving cos of theta is equal to 0.82, and I'm telling you that theta lies between 0 and 360 degrees. That means normally, because this is a normal theta, there's only going to be 2 solutions within that period. So first thing we do is we do arc cos of 0.82 on our calculators, and that comes out to be 34.9152 I'm trying to make it as accurate as possible. Now, cast diagram, so let's go back to our little cast diagram. It's called cast because it spells cast. You can think of any kind of acronym to help you remember. I had a lovely head of department along the way who used to tell me that South Africans can't teach. I was not impressed. Other one I've heard is all stations to Coventry. And there are various other ones that you could make up if you wanted to try and remember it. But it's called the cast diagram. You just got to remember which quadrant's which. So cos is here. It's in the 4th quadrant. We've got a cos diagram. This one says it's 360 minus. So my second solution would be 360 minus 34.9152. And obviously by now you've figured out that your answer button on your calculator is your best friend. And you get the answer is 325 degrees. So my 2 answers are theta is 34.9 and 325. Those are my 2 solutions for this particular diagram. So that's a normal bog standard answer. But let's move on to something where we have to adjust the theta. So this time let's use a different one. Let's use tan. So I'm going to tell you that tan of 2 theta plus 15 is equal to 0.89. And once again, let's put 0 between 0 and 360. So, quick little cast diagram. I need tan. Tan is 180 plus. See, it's beyond 180, so it's 180 plus. This is less than 360, so it's 360 minus. This is less than 180, so it's 180 minus. As long as you remember 180 and 360 are the 2 important numbers, it should make it easier to learn. Right, so the first step we do is we need to do arc tan. So arc tan of 0.89, it's always where we're going to start. And my calculator tells me that's 41.669. Now, what do I do next? Well, I'm going to use my cast diagram to work out the next value. Now, I've done nothing with the 2 theta plus 15. I'm leaving that till the very, very end. That's your last step. So for now, we are just working with this. So the other version is going to be 180 plus 41.669, which is 221.669. Okay, now here's a little hint for you. You see this 2? That means I can fit 2 graphs into my normal 0 to 360, which means I'm going to go around again. Now, graphs repeat themselves every 360 degrees. So what I'm going to do is I'm going to add 360 to these 2 answers. So next 2 answers would be 41.669 add 360, and 221.669 plus 360. So if I add 360 to this one, I get 581.669. And if I add 360 to this one, I get 401.669. I mean, on the surface, let's face it, they look far too big. So we're going up to 360. Now my last step is to say, well, I've got my four solutions, the four underlying things here. But what I was actually after was tan 2 theta plus 15. So my last step here is I'm going to undo my 2 theta plus 15. So 2 theta plus 15 is equal to 41.7, or 221.7, or 401.7, or 581.7. Now all I'm left for me to do is to subtract 15 and divide by 2 in every single one of my answers. So the first one I get is 13.3. My next one, minus 15 divided by 2, gives me 103.3. So let's make it 103 because we're doing 3 significant figures. My next one is 193. So you can see it is within my range. And the last one, take away 15, divide by 2, is 283. And there is my 4 solutions. So instead of drawing a diagram, all I've done is use cast. And where have I used cast? I've used cast right up here to just find my second solution, which is 180 plus. So we do that before we do the adjustment of the 2 theta plus 15. Right, now let's do what happens when we have a negative one. So the cast diagram, strictly speaking, is for positive values only. So what happens if I've got a negative? Okay, so let's do sine. So sine theta equals minus 0.3. And once again, let's pretend, oh no, let's make this minus 180 to 180 for a change. Do exactly what you normally do. So we're going to find arc sine of minus 0.3. And that's going to give me my first value. Oops, I forgot to put in the negative. And it's minus 17.4576. That's my first value. Now, if I go to my cast diagram, sine is 180 minus. So I'm going to do 180 minus this value. So 180 minus 17.4576 is 180 minus my answer, 197.4576. Okay, so what do I do with that? Well, once again, these things keep repeating, don't they? Every 360 degrees. So here's my 2 base angles. I'm going to add 360 to both of them. Now, hopefully you understand that there's no point in adding 360 to this one. So all I'm going to do is add 360 to this one. So what is minus 17.4576? Add my 360. Hopefully, you'll be able to say, oh, hang on, there's no point in doing this, miss, because guess what? It's out of the range, and you're quite right, it's 342.54. So that one doesn't work. Right, this one, if I add 360, is going to be too big. But do you know that you can also subtract 360? So let's try taking 197.4576 and minusing 360. So 197.456 minus our 360 is minus 162.54 degrees. Now, this is a normal graph. This is a normal 360 range. Sorry, I didn't realize I didn't show you that one. Which means there should be 2 solutions. And guess what we've got 2? There's one. There's 2. So my two answers to 3 significant figures are minus 17.5 degrees and minus 163 degrees. And those are theta. So the cast diagram also works with negative angles. Just remember you can always add 360 and subtract 360 with all of these. I hope that's helped.